everyone. Quite the crowd of people that want to take a nap for 30 minutes. So I hope I don't disappoint you. I'll first point out an embarrassing moment I had just a couple minutes ago. I'm sitting there and I'm looking at this picture. This is the new road cut on Kansas Expressway, the new part. And the gentleman behind me, I hear them say, "No, you're not in trouble. No, you're not in trouble. No."
It's just my nature.
This is my embarrassing moment here. And I hear the one gentleman say, "Oh, that's just beautiful. Gorgeous." And I'm looking at this road outcrop because this is special to me. Some fancy geophysics went into this for a long time. It was a surgical maneuver we did that saved $1 million in the project. It was really a neat thing. And so for me, that's my road cut. I think it's gorgeous, beautiful area. If you haven't seen the road yet, go down there and drive down it. And I'm thinking, yeah, I almost turned around and said, yeah, I know, right? And then they said, those golf shoes are amazing. So anyway, yeah, I hope they are, you know.
Hey, to each his own.
Yeah, right. Anyway, but the road cut is gorgeous as well. So maybe not as much as golf shoes, but you know. Anyway, all right, let's get started. Let's try to condense a whole lot of geology into a few minutes here. And I had to bring my working clock because apparently that one is right twice a day, but not right now. So anyway, so can anyone hear me all right? We're good? Okay. All right. I tend to talk loud, so I hope I don't scare you. And up is down on this. So, okay, so figured I have a obscure title of the Rocky Pass of Greene County. If you're looking to have like some sort of drama, historic drama of Greene County, you've come to the wrong talk. This is about geology. So I'll give you a second to leave now if you need to. Like, oh, this talk sucks. Anyway, but this one will be the geology. Now, every day we go through Greene County. We drive through it, or if you live in other counties, we drive past rocks, road cuts. You walk on top of the stuff in the courthouse. I've got pictures in here you'll see that kind of bring the courthouse, the old historic courthouse, kind of into that geology conversation. And it's fun because geology is all around us. There's a fun saying that I will completely butcher, but I think it's something like we're here by written consent of geology or something like that. I've condensed it down and made it worse, but we are indeed here by geologic consent. And we do our, I told a guy one time, an engineer, that my job is to constantly negotiate the conflict between humans and geology. Makes sense in a way, so. All right, so let's talk briefly about the geologic time, and I mean really briefly. So I'm going to try to keep this related to not Christian County. Wow, that's a traitorous statement there. Greene County. Anyway, and so this, oh man, this scale here, it's kind of hard to see. It's a corkscrew of geologic time. And of course, with my laser pointer not working the screen here, boy, we're losing a lot of stuff here. But Greene County has a few geologic time periods that it represents very nicely. One is, and I'll expand on these, the Ordovician and the Mississippian, and then a little bit of the Pennsylvanian. So we'll get into those a little bit here in more detail. Most of the time, you guys that have brought me fossils and rocks and call me and say, hey, what's this? Or what do you think about that? Are in those time periods. There are other time periods that exist, obviously, but they are not preserved in Greene County. So just for the sake of brevity today, we're going to stick with what's in the county to some degree. Okay, so to understand today, the way the world looks today, if you were in, this isn't flat, by the way, this is round, it's a globe. So there's always that one person like, it's flat. Yeah. Like when it says the Flat Earth Society has members all over the globe. They do. So anyway, to understand this Earth of ours, but to understand the Earth today, we must understand the processes that led to this. How did our continents get here? How did the rocks form? It's very important to have us understand geology, how it works, how to fix it when it's a sinkhole, how to interpret it when we're mapping it. Very important. I'll use a quote by Carl Sagan. Everyone knows Carl Sagan? Okay, except for the young guys here, probably like, who's Carl Sagan? Did he play for the Eagles? No, he didn't. They played like he did the other day, but anyway, um, Carl Sagan was a famous astrophysicist, and one time he was quoted saying, "If you want to bake an apple pie, first you must create the universe." You think about that, yeah, it's true. Same with geology. If you want to understand today, you have to understand where we started because every single process, geologic process from, the time that Earth was a glowing ball of lava to today leaves some signature that we can interpret today as we map, as we interpret that geology, as we work with that geology. So to start out, Greene County was this, a glowing part of a glowing ball of lava, much like it is during the summertime here. So in temperature. So it's fun stuff. And as we move along, it starts to cool down like it does in hopefully February, because it hasn't yet. We start to form rocks. We start to get that first crust. Now, we don't have that crust here in the county necessarily. You can't go out and look at it like you can in places in Canada, Wyoming, Australia. But below our feet, thousands of feet below our feet right now, we have some of this rock, this beginning rock of our planet. Oop, a little faster on the trigger. Okay. So, fun part is all sorts of stuff at the same time was starting to bombard the earth and bringing in things like minerals, gold, silver, copper, nickel, iron. Those didn't occur here naturally. Those were brought in by space junk. So as space debris was hitting the Earth, it was bringing in all this cool stuff. Now, we all know rare earths, right? We've heard that numerous times in the news. Rare earth, rare earth, rare earth. What the heck does that mean, rare earth? Well, it means it's rare on the Earth, but in space, they're very abundant. So as those meteorites with those minerals collided with the Earth, it brought in those rare earth minerals, which incorporated in our crust. So that's how we mine them today. Hopefully 2,000 feet below our feet there might be some rare earths in Greene County. Anyway, that's a future talk, um, but it's kind of fun to imagine it. Even most of our water came from comets hitting the planet early on because there was no water in the beginning. And fun fact, yes, most of the gold on Earth was delivered through meteorite impacts, so it's kind of fun. When we look at meteorites, we see a lot of those rare earths. We see gold, even see diamonds in there as well. Small ones, nothing worth anything, but a lot of cool geochemistry can be done on meteorites to help explain what we are mining today, what are we looking for today here. So Missouri does have a lot of silver in it as well. People don't realize that. Most of our lead mines, except for the ones in Greene County, we don't have silver here. Most of our lead mines are actually silver mines. The silver pays the bills. The lead is just the cherry on top of the cake as far as financing goes. So things get cooler. So if you were here early on in our geology, you would have cool volcanoes, both near the St. Francis Mountains on the east side of the state and also in Arkansas. And today, if you walk a gravel bar, you see the chert. That's the rocks that are on a gravel bar. That chert initially was silica that was pumped out by these volcanoes that were all around us, and then pumping that silica into the seaway. And then as it dropped to the sea floor, it started making these like silica deposits. And so that's why we have gravel bars today, is because of volcanoes back then. And the Earth looked different. Now, I showed you a few slides ago what the Earth looked like, round. Anyway, and here it is, flattened. No, anyway, so this is the way the Earth looked like. We would have been out in the middle of the ocean. I wish the pointer worked on this screen, but it's down to the lower left. Well, you can kind of see Florida on the very bottom. That'll give you a reference. So we're close to that. But the Earth looked much different than it did today, or does today, because of plate tectonics and uplifting and all these different geologic processes that have an impact on what we see today. And of course, now we're going to kind of more focused on what's going on in Greene County. We start to have stromatolites, which are a fossil that a lot of people bring to me. These are these kind of cool. Well, actually, I'll just show you here. There, this is a slice of one. These cool algae colonies that people find all the time. They take pictures, send them to me. I think some of you guys have had some that I've looked at. These are really cool. You find these mostly in the northeast corner of the county, where these are a little more prevalent. But they're cool. They tell a really cool story about um, life on our planet. Now, this is where it gets fun because up to this point, fossils really aren't that abundant. And the geology is interesting, I guess, to some degree, but again, we like fossils. So, um, when we get to the middle ordovician in Greene County, again, we're still in the ocean. We're getting closer to the equator. So things are warming up for us. I mean, we're still pretty far south, but we're getting close to we're moving toward the equator, is what I should say. And we're starting to see some really cool life, most of which, like this, big cephalopods, these big, like, coil or big cone-shaped squid in a shell, trilobites, crinoids, all the stuff that you guys find out there in a creek or your yard. Every time you look at a rock, these fossils exist. Now, maybe the same age. This stuff, again, is if you live up in the northeast corner of the county, you'll encounter rocks of this age, and you'll encounter the fossils within those. Now, unfortunately, the rocks here, like the Cotter Formation, things like that, so they don't have a lot of fossils in them, but when they do, they're really cool and unique. Now, the Mississippian. Now, this is what dominates everything in Greene County, the Mississippian period. Not to be confused with the Mississippian period in archaeology, totally different. They're making pottery. These guys are not doing that. So, by any means. But it's dominated by, so we have the Burlington limestone, which you see everywhere. It's under your feet right now. It's the tile floors. It's the walls in the courthouse here, which I'll talk more about that here in a second. Um, the rocks you drive past on the way here, the cool cutters and pinnacles, those big pinnacles of rock, most of those are Burlington limestone. It's our largest cave producing unit in Greene County. It contains pretty much everything. Most of the things I work on are in the Burlington limestone. And the cool part is that the Burlington was deposited in a shallow, warm sea. Think of like the Bahamas today. We were close to the equator. It's warm. You can only deposit limestones in warm water. So think of this tropical water. Think of the exact opposite of what we had this morning. So that was what Missouri was like. It's called the Kaskaskia Seaway. I'll test you later on that. So, and the sea extended up into Iowa, where the Burlington Formation got its name from Burlington, Iowa, and all the way down into Arkansas, northern Arkansas, and then on to what Indiana, and then out a little bit into Kansas. That was that inland sea at the time. So most of you guys, when you bring fossils to me or you see a fossil, you're looking at crinoids, which is the upper right, this flowery-looking organism. They're not plants; they're actually animals related to starfish, so they're echinoderms. We do have shark teeth in the Burlington. They're rare, but they're there. Anybody seen Smallland Cave? If you go take a tour of Smallland Cave, they are in the ceiling there. I think they point them out to you. So there's a number of shark fossils in that cave. In the ceiling, then if you take the wild tour in the back, you can actually see one of the long fins. The leading fin is called a spine, and there's a big spine in the back of that cave too. It's just gorgeous. So anyway, this is what the Mississippian Sea would have looked like at that time, or what Greene County would have looked like at that time, which is kind of fun to think about when you look past these rocks, you drive past them. This is what you should be thinking about, that cool, shallow sea, less than 300 meters deep, sunny, warm, land not in sight anywhere. But what does it relate to us? So again, I said this is the main cave producing unit or formation in our county. We have lots of our material comes from this. Our crushed up rock, you name it, building materials come from this unit. And anyway, so when you walk around the courthouse, this is a fun thing. So I came up here last week and took pictures of the floor when the first or second day back, and it freaked everybody out because everyone started paying their taxes and all this stuff. I'm like taking pictures of the floor, and they're like, "What's this guy doing?" I could have had like the fentanyl, like that thing, and they would have been like, "Oh yeah, that's fine, it's normal." But this guy like taking pictures, like, oh, it's creepy. Call the police. So anyway, so I like duck on the third floor and go, I gotta hide, but it was fun because over the years people have taken pictures. Harold Bench was great for this. He would take a picture and he'd send it to me. What do you think about this, Matt? What's this? And so as he walked up the steps and through the courthouse, And so these are mainly on the steps. These are areas that you're going to walk. I purposely walked where everyone walks so that you can see the same thing. These are on steps. This is Archimedes. This cool looks like an Archimedes screw, and it's a cool organism called a bryozoan, which is basically a giant apartment complex for filter feeding organisms. Sounds boring, but it's actually kind of interesting. But this is the only one we have in the courthouse that I've seen so far, and it's just this perfect slice through it. So it's a fun one, and it's actually one that Harold Bench had pointed out to me a number of years ago. So it's always kind of cool to look at that on the way up. I think it's on the between the first and second floor, if I remember correctly, on the east side of the building. This is a common fossil in the Burlington in a way, but you just see the looks like lace. These are the fronds that come off of this. You don't really see the center section. For some reason, those break up here in the Burlington. Brachiopods. Now, these are a little weird because they're all split or cut. And so you kind of get this weird cross section through them. You'll just see these kind of like half moon little darkened areas that are just to the right of my finger. And then below, you'll see kind of where it was laying flat and then cut through long ways. So they don't really give you the true. Actually, let me see if I've got one of that slide back here. Not great ones. Lower right, you'll see some of the brachiopods. There are tens of thousands of kinds of brachiopods. I mean, they're just prolific. Most fossiliferous beds contain some brachiopod to them. We still have them today. We just have one, and but they used to be much more abundant. Obviously, I've seen entire rock units that are nothing but brachiopods. I think we all have seashells, but a totally different organism. Won't get into that boring detail for you here. But anyway, crinoids. That's the little circular thing up to just above my finger there. The Burlington limestone contains between 10 and 15,000 fossils per cubic yard. So when school kids come out to visit the museum, like, are we going to find fossils? I'm like, Stevie Wonder could find fossils out here. Like, who's that? Yeah, yeah. So anyway, so and also I'll point out stylites because I get this question a lot. Below my fingers, you can see what looks like a if you have this as an EKG or something with you're dead. I think. I didn't ask my wife; she's the nurse, but I should have asked her. What does this mean? It means you're dying. But that is called a stylite, and what it is chemical weathering in the Burlington limestone. It creates these really cool jagged looking lines in the rock. There are a ton of those. So if you walk in the lower level from out front and you're walking down the steps, you look to your right, you will see a ton of those stylites in the wall on the right hand side. And then, of course, just all of the steps around here, too. Very, very common, but not a fossil, it's just chemical weathering. And so during this time, we look much different now. Things are starting, you kind of see a little bit of Africa poking out there. You can start to see things that are a little more recognizable. We're a little closer to the equator. It makes sense. We're depositing limestones, which only form in warm water. We're making limestone today in Florida because it's warm down there. And so, again, we can look at what's being formed today, and we can kind of extrapolate and answer the questions of how did that limestone form in Missouri. And so you can see everything is still together land wise. We don't represent, by time the land started to split apart and form the continents we have today, Greene County was up above. It was uplifted enough to where we're in an erosional stage now and have been for a long time. That's the weird part as a geologist. This time period will never be deposited. No one is ever going in the future going to find rocks deposited today in Greene County. It's kind of sad. So we won't really leave our mark on anything. Even our plastic will be turned into coal seams, I think. So it'll just be nothing. It's kind of fun to think about. At last, well, for the sake of brevity, I've taken off kind of the top of the heap of Greene County stuff, Ice Age stuff, and a little bit of the Miocene that's a little ill represented. But the Pennsylvanian, occasionally someone will bring me in a cool lepidodendron. I'll quiz you on the spelling of that later. But it's a shagbark tree, which is very common in the Pennsylvanian rock, mainly sandstones and shales in Greene County. But you guys always bring in these cool chunks of log and stuff like that of these lepidodendron. They're very common. They hold together pretty well, and that dominates sort of the uppermost geology of Greene County. And again, that's the sandstones that are dominant, say, up near Stratford and then out near the western edge of Greene County as well, has a lot of sandstones out there. And most of them are deposited during the Pennsylvanian period. And things get cool because the big coal swamps, things are really starting to heat up. You have 6 foot long millipedes, dragonflies with 4 and 5 foot wingspans. So if you hate bugs, it's not your favorite time to live. But if you do like bugs, it's the perfect time to exist. So most of the trees were actually ferns, giant ferns. We see ferns today growing all over the place on rocks, but they are just tiny little representative of what used to be a big, mighty forest of seed ferns. So anyway, questions. That was a lot of time for questions because I thought either I'm going to bore you to death and you'll just sit there and blink at me, or you're going to have questions. So I wanted to have some time. And if nothing else, we'll go back to work and be productive today. So
we'll ask questions.
Sure. Yeah, the golf guy's here. So in your gorgeous golf shoes.
How does the fossil that you uncover impede what you need to do when it talks about road cut or things like that, or do you just have to just take that into consideration as your
no, they're just it's just part of the rock. So as I joke, millions of fossils died for that road cut on Kansas Expressway. So and they do all the time for crushed road or crushed gravel parking lots and all that kind of stuff. Yes, we are not fossil friendly in this area. So you can't be. There's so many that are so common. So we don't care. Yes.
Could you talk a little bit about the surgical incision that led to the $1 million savings for the county in the very first slide that you mentioned?
That was wrong.
That's a specific question. Yeah, I can actually. Yeah. So we had a number of targets, caves, springs, and such that we had to kind of maneuver around on that section of road. We went out and did electrical resistivity, which is a geologic or a geophysical technique. I've talked on that a couple years ago. Oh, I'm sorry. Yeah, I'm supposed to repeat the question. Yeah, sorry for the people listening. So the question was, how did we kind of I'm going to summarize a bit. How did we get to that point where we could make that road cut and save that money? So what led us up to that road cut? So initially, the original plan was to have these big slopes laid back and all grassed over, which you do see along the road, but those can be costly. It's cheaper and easier to make that cut face or road cut like that. So I went out there, did a lot of geophysical exploration for a better part of a year, I guess, off and on. And we discovered that we weren't going to hit anything, that we had competent bedrock for at least the depth of that road cut and even deeper. That we weren't going to hit caves. We weren't going to hit a spring. We were going to hit these conduits. So once I was certain that we were going to have good, what we call competent bedrock, which is solid bedrock with no voids in it, we then went forward with the change order and started to blast. So just basically a series of holes, load them up and shoot them. And that's kind of how we did that. So does it answer for you or?
Sure. And so that change order is what led to the $1 million savings.
Yes. Yeah. And I didn't realize we did that. As far as the savings, until I was asked to write a letter for the construction company, and I just didn't know. And I said, well, hey, by the way, if I'm writing this letter, so they were going to apply for some award somewhere, and they wanted to have a little letter recommendation. I'm like, hey, by the way, how much do we save on that, just so I can add to the letter? And I'm standing in Harder House shopping, and they respond back like, it was $1 million. Like, oh God, and I didn't realize, but cool. It's fun when you can apply science to a problem, and it solves a whole lot of problems for us. So that was neat. So a good victory. That's why I love that road cut. So any other questions? Yes. Well, in this case, we couldn't remove material from the work site. So at that point, because of the permit with DNR, if you remove rock from that site, then you have to apply for a quarry permit, which is a whole bunch of red tape, big problems. So everything was used on site. All that rock was used as fill on site. So, and the little mound that was left was just kind of pushed, flattened out, and that was it. So. Yeah, now, if they had a quarry permit, then they could have moved that. That's why the giant pile. That's a good thing. If you drive in the south side of town, so Campbell up by the library center, there's that big giant mountain of rock. That's why it's there, because they can't move it from the site. They will have to move that. They'll have to use that rock as they develop on that property, because the minute they move one dump truck load, it becomes a quarry site, and they will not be in compliance. So there you go. That answers the question. And I never knew until recently, like, aha, that's why. So, yeah. These are good questions. I like this. Any other questions? All right. Oh, yes.
So I know it'd be millions of years from now, you were saying Greene County won't leave its mark. Will it just eventually erode?
Yep, it will. So here's the depressing part. So as the internal engine of radioactive materials just decay out, and we're talking, 4.5, 5 billion years from now, it won't matter because the sun will burn out then too. So it'll just turn into a red giant and bake us. God, that's depressing, isn't it? Anyway, geologists, we see that, yeah, we're like, oh, this is going to suck in a little bit. But when the process of that internal heat, when it stops, when we no longer have uplifting, when we no longer have those mantle plumes pushing things up, essentially everything will erode to sea level. And that's it. The last piece of land will erode away as a small beach, and that's the end of it. It'll just be a water-covered planet, very shallow seas everywhere, because everything will be filled in with material. And that's it. And then at the same time, the sun will expand. It'll start to use up all of its fuel, and it'll expand as a red giant, and then bake that water off in our atmosphere, and we will just be a rock floating in space again. So, right? Yeah. And Greene County, we will be part of that. So, any other questions that I can maybe uplift and get us away from that depressing future? So. But the cool part is that the process keeps going. It just, other planets, other places, and opportunities. So it's not, you're not really just, you're not killing off one. You're kind of setting the stage for something else. So, and possibly our planet then flings off into somewhere else, hits another planet, and then creates all the mineable resources and all that stuff for the next planet. So there's a chance. So, yeah. Any other questions?
You got that going for it.
Yeah, you got that going for it. Great Bill Murray quote there. Yeah, I got that going for it. Well, guys, thanks a bunch for coming out today. I hope it wasn't too boring.